Alright, I wanted to record this video and publish it on YouTube so it'll have a date so I can officially have a recording, a public recording of my theory, so if anyone else tries to take the credit for it. Because I think and I hope eventually people will understand the thinking and how it works, what I'm saying, and once they understand that certain pieces of it, then they're going to be able to use those pieces kind of like in a puzzle, kind of like building blocks, and they're going to be able to think forward, which I feel that I was able to do, and I'm going to mention for the most part how and why. So what I'm saying, and first off, what this is in regards to is tornado genesis. And so when I was younger, I saw a tornado here in Houston. It was actually formed on the west side because the storm was moving to the northeast, just like they do for the most part. And it formed on the west side of Interstate 45, just south of downtown Houston itself. Well, it picked up, that tornado picked up, and then it set back down as a larger, more destructive tornado to the northeast of that location on the other side of Houston. I believe it was in Chambers County or something like that, but it started in southern, at least by how it looked, it started in southern Harris County. So anyways, after that, I became obsessed with tornadoes and storms and started riding around and taking pictures of clouds. And living on the coast, I've seen a lot of water spouts. That's pretty cool. And then I eventually got to the point where I started doing experiments. Well, as you know, lots of people can make tornadoes, which they're not actually tornadoes because it's a tornado specific to a thunderstorm, but they can make vortexes or a suction vortex from something sucking or something spinning. Well, something occurred to me and I decided to try to make a tornado, which is really, I understand now, is just a suction vortex, by a totally different method that I didn't see anybody else do. I didn't hear about it. I'm going to reveal that eventually. So I set up an experiment. My parents had a separated garage, and it was big, and when the garage was empty, it had a smooth, for the most part, it doesn't have to be perfectly smooth, floor, and when there was no cars in there, we would close the windows, the garage door, and make it pretty much a static environment. Well, I would set up this, me and my buddies and my brother, we set up this experiment, and what was really cool, and I'm glad it happened, is we had to tweak it and had to do certain things for it to produce a suction vortex, aka a tornado, and we eventually got it to do it, and it was interesting how it would have to be just right to do it. So we got it to do it. We even put little bitty pieces of styrofoam on the ground, and when the vortex would go over it, it would spin them around and suck them up. But for the most part, we would use dry ice, and all the dry ice does is it makes the air, for the most part, it sinks, right? It makes the air on the ground. That's the key. It makes the air on the ground visible. So I remember watching, just like they say, an area of rotation start. So a large area of that whole area of the dry ice on the floor would start to rotate. Then the experiment, or the part of the experiment where the suction vortex would form, it would pull that area of rotation on the ground towards it. And then it would be conserving the vorticity, or conserving the spinning angular momentum, whatever you want to call it. Because it would start out like a very large area, but in the middle of that large area is a smaller area, just how like a circle works at spinning, or a tire, the closer you to the center, the faster it's spinning. Well, it would pull it in underneath the area where the suction vortex would form, and once it did that, it would spin up, and it would produce the suction vortex. And so I remember that. And then we did another experiment where we were able to we'd pour gasoline on the ground. I know it's dangerous. There would have to be, it couldn't be dead calm for this one. For the dry ice one, it had to be dead calm, static. Well, we would pour gasoline on the ground and light it on fire, and it would just burn, just like a puddle of gasoline will. Well, we figured out, because of something that I experienced in a lot of places. It's so simple once this stuff comes out later, and I applied this to, it's non-mechanical, it's nothing electrical, spinning, anything like that, but I would apply this thing to the puddle of burning gasoline, and it would instantly turn into a fire tornado. I mean, a brilliant fire tornado. It would whistle sometimes. It would just be real tight, because the heat was making it go up, faster than I would say the suction vortex that we created with the dry ice. So, anyways, it was brilliant. We'd take that object away, it would go back into just a regular burning puddle of gasoline. And in nature, we know, without anything spinning, and and these large fires, forest fires, sometimes fire tornadoes, fire vortexes will form, because it's easier than you think for a vortex or a suction vortex to form. Dust devils, hay devils. There's one on YouTube where it picked up the porta potties. That was a strong one. We've all seen them. I've seen some massive ones down here in Houston in the drier months in the summer. I mean, you could see them from miles and miles and miles. When it's really, really, really hot. And there's people that realize that if we could see in the air, all the little areas of vorticity, little spinning areas, they're all over, eddies, whatever. So somehow they come together with the heat, and it makes a vortex, dust devil, whatever you want to call it. So the point is that it's pretty easy. So now, jumping forward, I had been off work, had an injury, and so I was sitting at home, and I came across some tornado videos on YouTube, and it kind of reignited the passion. And I started watching tornado videos and thinking about it, and I happened to stumble upon Pecos Hank Scheima, his videos, and he interviewed Dr. Lee Orff. Well, Dr. Lee Orff has been doing these simulations, and I also saw Skip Talbot's videos, and he's theorizing a tornado forming from the ground up formation, which I'm going to get to in a minute. And it got me thinking about what I saw in the experiments I did with the dry ice that showed what the air was doing. I saw similar things. So, and Dr. Lee Orff, he theorizes the SVC, and he talks about how it's conserving. There's little mini areas of vorticity that the mesocyclone is pulling to itself, and those areas of vorticity, little mini vortexes, are being sucked into the main area, and it conserves and whatever. Okay, so that was pretty cool. But anyways, the main thing I'm talking about is the SVC. Well, during all these regular storm chasing videos, thanks to the storm chasers, you see these octopus arms that come out of the vortex. You see lots of horizontal vortexes. You see them right up the side. You see satellite tornadoes. You see multi-vortex tornadoes. You see all that. Okay, so I was like, oh, that's pretty cool. So it made me want to do these experiments again. I did it once since I moved into the house I'm in, because when I was younger, in my mid to late teens, I did those experiments. I'm 38 now. So I decided I was home from work, after seeing Skip Talbot's video about his theory and vorticity, and how the thunderstorm may form a tornado, etc. I was like, oh, I'm going to do my little experiments again. So I did it, and what's cool is I couldn't get it to work. I couldn't get it to work because it's hard to get it to work. Things have to be just right. It's kind of like in real life. Not every supercell, not every rotating supercell creates a tornado on the ground. Um, and finally, I got it right. And I actually made the temperature of the dry ice fog a little bit warmer, which made it more buoyant. And I think I moved something in the way my experiment set up, and it naturally, without me inducing anything to induce any kind of rotation, um, it did it. You would see an area of rotation, a large area of rotation start. It would conserve it. You'd see little bitty mini areas of rotation, and it would tighten up that rotation. And you could see all this because the dry ice is showing you what it's doing. It's making the air on the ground visible, which doesn't happen in real life. And so it would pull it to, because I know from my experiment now where the the vortex strongest area is going to form, where it wants to form, where it's most efficient. And I would see it, gather it to it, and it would conserve that vorticity, and it would spin up a vortex, and it would start. You could see the upward motion, you could see it spinning, you could see the funnel and all that, because it's marked, not by condensation like in real life, by the dry ice fog until it evaporates and dissipates, the carbon dioxide, because that's what it is. So I filmed it. Then I started watching it over and over again, the recording, and watching it in slow motion. And in slow motion, I saw a horizontal vortex going almost all the way around the main area of rotation. And you could see the tube, and you could see it roll up the main area of circulation, get carried up on the upward motion of the funnel, and basically ride up the funnel. I saw that. You can see it in slow motion. I scrutinized myself, so I played it back and forth to make sure it's not just a long string of connected dry ice fog. Like, you can actually see it spinning. You can see the tube. You can see it rolling up the main area of rotation. I found in that footage, I found a satellite vortex spin up to the side of it and then get sucked in, and just like the people say, when it met up with the main area, it added to it, and it spun up, and it got sucked into the main area of circulation. I saw mini vortexes inside of that area of circulation. I saw, I even have, and this is all on an iPhone, so the resolution's not very great, but I even saw these little bitty octopus arms come out. And when you rock it back and forth and frame by frame in slow motion, you can see the rotation of it. So it's not just like a little arm randomly sticking out of fog. It's the dry ice fog is getting sucked into these little bitty areas of rotation, and you can see it. Then there's one where it looks like a horizontal vortex on the ground, and you can see it. This one happens in tenths of a second. You can see it spin up, and then you can see it eject that dry ice fog out of it real quick. It goes and just ejects it out. That happens in tenths of a second. The other stuff is slower, and then the main horizontal vortex that rides up the funnel I was talking about earlier, that happens, and it takes a few seconds, so it's slower. But it's not 100% crisp, but you can definitely see it, and I'm definitely would let other people see it, because I've learned in some of my other studies that I do, you have to try to knock your own theory down, and you have to subject it to other people to knock it down to see if it's going to stand. And that's why one of the reasons I'm putting out this video. So, and I got to credit some of this to, and I could be wrong. I'll feel like an idiot. I'll get over it, right? So, in one of Dr. Lee Orff's videos, he talks about the pressure gradient, and the pressure gradient created inside of the mesocyclone, created by the supercell, etc. Well, basically what, I talked about theory. What I'm theorizing for right now is that the pressure gradient created by the mesocyclone. The mesocyclone is created by the supercell, and the supercell and the rotation of the supercell, and all that's created by the right meteorological conditions, etc. I'm not denying that, but I ask myself, and other people ask me, they say, well, how can this be anything like real life if you're not making a thunderstorm, you're not making a supercell, you're just playing with dry ice. Well, I understand that, and that is true. But when I just mentioned Dr. Orff's experiment a minute ago about the pressure gradient, basically what I'm saying is the low pressure inside of the mesocyclone itself, and the pressure gradient that it creates is a byproduct of the supercell. And so in basic physics, the pressure gradient, or even low pressure, it wants to find the most efficient way to neutralize that, if that's the right word, that pressure gradient, equalize the pressure gradient. That's the right term. Equalize the pressure gradient to fill that void, right? To equalize it. And there is physically, as far as physics goes, there's a more efficient way to do it. So the pressure gradient, the mesocyclone in meteorological terms, it has to, and it wants to, get all the air within, now I don't know how far of a vicinity, within a certain vicinity of it, square miles or whatever, to cooperate with it. So it's always going to be trying, and this could be when tornadoes are trying to form, and these are the times they don't form. I'm not exactly sure, but I do know it's always going to want to create the most efficient way to equalize the pressure gradient, much like, due to the Coriolis effect, much like the water in a drain, it's going to naturally spin, and it's going to make a little vortex, and that's going to be the most efficient way for it to disperse and to transfer the liquid or fluid from one area to another, to the low pressure, to drain it out or equalize the pressure gradient. But anyways, it's going to want to find the most efficient way. So it's always going to be trying to do that. Now, in the meteorological or atmospheric setting, I'm saying that the mesocyclone is always trying to do that, but it can't always do that. So basically, the pressure gradient, the mesocyclone, is always trying to get the air on the ground, because that's when we call it a tornado. We call it a tornado when, now, if you notice, now there's so many storm chasers, and thanks to storm chasers, you can see dust rotating or being picked up, and a lot of times you'll see it to the side of, or directly underneath of the mesocyclone, and they'll see it and they'll say tornado on the ground, yet the pressure isn't low enough inside the funnel, which I'm saying is already there. Y'all know it's already there. It's just not a condensation funnel yet, because the pressure isn't low enough for the air to condense to show us that funnel, right? But basically, when the rotation on the ground gets pulled in and conserved right underneath the mesocyclone, then the pressure is going to drop. You're going to get your condensation, which it'll have a condensation funnel when the base, these are your long rope tornadoes, when the base is far away from the base, when the base, I mean on the ground, is far away from the base of the mesocyclone or the supercell. But then whenever, and this is why your more destructive tornadoes are just straight up and down in line with the area of rotation on the ground is lined up with the rotation underneath the mesocyclone, and it just becomes very, very efficient, very strong. I don't know if these more destructive tornadoes have a lower pressure, a stronger pressure gradient. I'm not exactly sure at this time. Working on that. You guys can tell me if anybody's been successfully able to get the air pressure inside the heart of a tornado or of the mesocyclone at different heights. The ground, I actually think higher would be better, You really need the whole thing, but I'm not sure. Maybe they are. The actual pressure, just like we have in the hurricanes, we know what the lowest pressure recorded was in a hurricane, etc. Well, what about in a mesocyclone or a tornado? Um, Kind of lost my train of thought there, but let me try to get back onto it. Oh, yeah. So I was talking about the straight up and down with the more destructive tornadoes, and then your long rope tornadoes where the ground base of the tornado is far away from the base of the mesocyclone. Um, so it's always trying to pull the most efficient way. This is what I was getting at. The most efficient way to equalize that pressure gradient is for the base to be in one column. To be in one column. That's the physically, as far as physics goes, the most efficient way to equalize this pressure gradient. So what I'm trying to say is it has to get the air on the ground to cooperate. And after looking at a decent amount of, well, actually probably not a decent amount, maybe a 1/100th of the storm chasing video out there, you can see kind of different phenomenon where some dust will blow up and you'll see different things happening, and then the rotation the condensation funnel will form a rope tornado. But eventually, when that base, the ground base, lines up with the base of the mesocyclone, that's when your strengthening occurs. And that's what I was seeing in my little experiments. So the pressure gradient in the low pressure is a byproduct of the supercell. Now, it's not to disregard the mechanics of a supercell and all the meteorological conditions and all that, because the more violent a storm is, and when all these meteorological conditions line up, you get these tornadoes, and then you get these really destructive tornadoes. So I'm not minimizing that. I'm just saying, thinking of it in a way of the pressure gradient and the low pressure, the mesocyclone, is a byproduct of the supercell. So what I am implying is that it doesn't need the supercell. Now, the supercell it definitely affects it. The rest of the supercell, where the rain is, the hail, all that kind of stuff, the outflow, RFD, all that stuff. It does, obviously it has to, because it's part of it, play into effect. But there's no way to get this pressure gradient and this low pressure apart from a supercell. And this extreme that we get with these tornadoes. So no, you can't have one without the other. But if you could, and you could create a pressure gradient and low pressure, what I'm saying, because of what I've seen, is it does something similar. And that's because of the physics. And so that's simply what I'm saying. I made the air visible on the ground with I can tell you this, I create an area of low pressure. It's close to natural as possible. I don't use anything spinning. I don't use anything sucking. I create an area of low pressure. And I don't have anything to induce rotation. The low pressure and the pressure gradient does it on its own. And besides, the supercell is already rotating, right? The mesocyclone's rotating, low pressure rotates, counterclockwise. So there you go. I mean, it's not that difficult. But the question is how does it get the air on the ground to cooperate with it? Well, it already wants to do that. And what I'm saying is low pressure or a pressure gradient, if you can duplicate it apart from a thunderstorm. Now, I understand there's different factors involved and all the other kind of stuff. It's gonna do the same thing, and I'm just saying that's basically what I've seen. And there's little experiments. It created the little octopus arms. Similar stuff to what we've seen. It creates an area of rotation away. It starts to conserve it. It brings it underneath the base of what would be the low pressure or the mesocyclone, which I'm not making the mesocyclone. And when it gets under there, it spins up a little suction vortex. It's able to do its most efficient way of equaling the pressure gradient. So that's what I've seen. Now, I am claiming that I have seen what causes these, because I've seen it happen, causes these horizontal vortexes and stuff. And you know how we could solve this if we could, and I have some ideas of how we could see more. It's really about seeing, because as far as the what's happening on the ground, which is what everybody wants to know, we can't see it. We can only see the dust that it kicks up, and whatever it sucks up, water maybe a little bit in a water spout, and the condensation. That's all we can see. If we could, on a mass scale, and it would be just terribly difficult, possible in theory, but in practicality not possible. If we could make a large square mile area of the air visible on the ground, you'd be able to see what it's doing. You'd see this area of rotation start long on the ground, a good amount of time before the tornado forms. You'd see it conserve the vorticity. You'd see it pull it in underneath the base. I mean, you'd see a lot of stuff sooner than we see it now. And so that's what I'm saying. And so another thing is the Dr. Orff's SVC. I've seen something like it. I heated the dry ice fog and made it more buoyant, and then I saw these little bitty, barely spinning, all these little mini vortexes in a line going towards the main area of rotation. Coincidence, whatever, I don't know. But what I do see, I'm going to get to the horizontal vortexes around these tornadoes and the octopus arms, is in my experiment, I can see all the air on the ground around this vortex moving. I can see what it's doing, right? And then every now and then you'll get an area almost like a line. It reminds me of what they call the inflow jet. Like you hear Reed Timmer and guys talk about it, the inflow jet. And you can see it on a lot of these videos. You see you see the dust and the dirt almost in a line sucking in, going in a straight line towards the base of the tornado. Well, there's areas that'll be stronger because the whole area is rotating and getting sucked into the tornado, but some of the air that's going in will be in more of a straight line, right? And get sucked into the base, just like the inflow jet will get sucked into the base of the tornado. Well, you have air, so let me make it to where you can see. So I'm gonna try. The tornado is right here, okay? The air all around it's getting sucked in. Well, there's an area where it's kind of more of a straight line. It's going in to the tornado. Well, okay, remember the tornado's right here. I got to move this hand. Here's the area. Here's the inflow jet going into the tornado right here. It's strong. It's almost in a straight line. But the air around the whole base of the vortex is still rotating around it, right? Well, this air is traveling this way, right? Because as it's coming like this and it's going around the base, well, it hits this area that's stronger as far as this motion, and guess what it does? It stops it, but it's already going this way, so it does this, and it starts to make a loop. It starts to roll, right? And then it's sucking it into the vortex, and so what'll happen is you'll have this air collide with this thing. It'll want to stop, so it'll yank it back, it'll roll, and then it'll get sucked into the vortex, and you'll see this horizontally rotating column of air get sucked into around the vortex, and you'll see it roll up the vortex. You'll see a little octopus arm. The octopus arm thing that I have in my footage is awesome. I had to go over it over and over in slow motion to see the rotation and make sure it was not just a little point sticking off or just a little from gravity, the spinning where it flings out a piece or something. I had to make sure, and you can see it spinning, and you can see a little octopus arm come out, and you can see the motion of it, and you can see it go away. You can see that. You can see these mini vortexes. You can see a satellite. You can see subvortices. You can see all this stuff. But just to try to show you what I'm talking about, which I was talking about with somebody today, you have areas at the base of the tornado that are traveling more straight line towards, kind of like Dr. Orff's SVC. If you watch his video, it's like a tube long looking thing sucking into the tornado. Um, but some areas are stronger. At the same time, all of the air is going around it. Well, when this air comes around, like I said, and hits this area, it wants to stop it. It collides with it and rolls, and it starts to spin that way. But that's moving into the tornado, and so that rotation I'm talking about gets going, and when that makes a low enough pressure or dust gets in it, in real life you'll see it from the condensation or dust or whatever it is. But with this dry ice fog I'm talking about, you could see all this because it doesn't have to condense. You can see it. So you can see air getting hauling into the base, and then it's rapidly changing directions. And when it encounters the updraft, the vertical motion of the vortex, when it encounters that, when it's going sideways and it encounters that, it twists it, and so it'll roll up the side of the vortex. So that's just an example. Summarize the low pressure and the pressure gradient wants to find the most efficient way to get all the air in the area to cooperate in order to equalize the pressure gradient in the most efficient and fastest way possible. When it gets all the air cooperating in the area from the base, and I'm going to go back to the thunderstorm scenario, from the base of the mesocyclone all the way to the ground, when it dominates the air, that's when the rotation on the ground is in line with the rotation underneath the mesocyclone, and you get your tornado. That's the most efficient way to equalize the pressure gradient, and that's a tornado. And I'm just saying, even though I didn't make a thunderstorm, that's what happened in my experiment. So leave your thoughts and comments below. I'm prepared. Don't be hateful. Don't be rude. And I don't know what you can, everybody's entitled to their own thinking, and I encourage thinking. And hopefully you can understand what I'm talking about, and maybe you can think further and stuff like that. But don't take what I've said, assuming that there's some truth to it, as credit to yourself. Okay, because I'm putting this out. One of the reasons, the first reason, is at a moment in time. Now, for all I know, there could be people that have already thought of this and stuff like that. But at a moment in time to show, that I'm putting this forth, because I certainly haven't copied off of anybody else. The only thing that there's people that have put puzzle pieces, Skip Talbot and Dr. Lee Orff. But the experiment I did, I copied off of no one. I saw no one from anyone else. And hopefully it can help. But there is another experiment I've done that adds to this, that's independent, that I think may be a factor based on what I've seen, not but seen, that can intensify tornadoes and help with rotation. But let me know what you think, and this is my first video on this subject. I have not very good quality pictures on my phone. I have video. I can send some pictures of the octopus arms and the horizontal vortex that wraps around the rotation and rides up it. That's too hard to see. You can only see that, and you can kind of make it out if you know what to look for, but you can see it because you can see the motion in the video footage, and I can't send that out right now, but I do have photos labeled, not the best quality, of satellite vortexes, mini multiple vortices inside the main area of circulation, the little horizontal vortex connecting to the main area, and things like that. I have pictures of those that I can show. Thank you all for the time.